us see a new pattern which is a combination of left justified as well as right justified. Now, you might wonder that can I again club two programs which we have studied in our previous session? No. If any triangle is going to be vertically mirrored, then only we can have a merging of operations possible. Suppose if I have a pattern which is on the top and the same pattern is mirrored on the lower side, then we can go for thinking of merging two programs. But here the mirroring is done vertically. I have not placed a mirror horizontally, I placed a vertical mirror. So when I have a vertical mirror, how exactly these operations are going to be done? So the operations are going to be done in this fashion. So let me draw a grid around this particular structure and analyze the rows and columns for this. So I'll have a grid Now, when the triangle is going to be mirrored vertically, in that case, as usual, n is going to control the number of rows. Sorry, n is going to have the total number of rows. R will be still the row variable. S will be still the space variable. Now here, what I'll do is, from left till mid, I'll use a variable called as C1. And after mid till right, I'll use a variable called as C2. The only change which you're going to experience when you compare this with the previous code is that the entire row in that particular pattern was printed using a variable called as C. But this time I'm going to have a variable C1 to take the control of the pattern from left till mid, and after mid till right we'll have a new variable called as C2. Let's analyze this particular pattern with the values of the variable. So let's try this for various values. So let's say n. Now at the beginning r is 1. When r is 1, let me take r, let me have r as 1. Do always participate in the entire discussion, because whenever I take a pause, make sure that you also spell the values of these variables. Then only the program will be more interesting. So we'll have a virtual interaction. So you're going to spell the values along with me. So r is 1 at the beginning. Now when r is 1, I'm supposed to start with spaces. So let me take a variable s and count the number of spaces. So here the spaces are going to be, let's start this count, 1, 2 and 3. So I'm going to have 3 spaces altogether in this place. So 1, 2 and 3. Once your s completes this task, then who's going to take over? The variable which is on the left hand side of the pattern is C1. So let me have C1. How many asterisks this C1 is going to print? Only 1 asterisk. Let me put 1. Once C1 completes this task, logically C2 should take over, but as such in this particular row we don't have any function of C2. So let me put a dash in this particular part, because if you observe at this junction of R and C2 we don't have any character. So as usual, after this I'll get the cursor on the new line. Now these are the contents which are going to occur, or these are the variable values which you're going to observe when we say about the first row. Let me revise it one more time. So when r is 1, first generate 3 spaces by the s loop. Then print one character using a loop called as C1. Then don't do any operation for C2 loop. Let's check whether C2 will remain idle for remaining stages. Now let's say this for second row. So this, when r is 2, yes, how many spaces? I'll have 2 spaces. 1, 2 spaces. I'll have 2 spaces. After that, once you generate 2 spaces, these are the 2 spaces, these are the spaces. Now after that C1 will take over. C1 will have 2 asterisks, let's say 2 asterisks. After that C2 will have only 1 asterisk, and then we'll take the control to the next line. This time when r is 2, you have a character on this particular C2. Now when r becomes 3, when r is 3, how many spaces are going to leave? Only 1 space. Let's say it at one stretch. Say it along with me. R is now 3. So how many spaces? 1 spaces. How many characters for C1? C1 will have 3 characters. And how many characters for C2? C2 will have 2 characters. Let's write it. When R is 3, how many spaces? Only 1. How many characters for C1? 3 characters for C1. How many characters for C2? 2 characters per C2. And then as usual, I'll get the cursor next line. When R is 4, finally, when R is 4, so this, how many spaces? 0. How many characters per C1? 4 characters per C1. How many spaces? How many characters per C2? 3 characters per C2. So I'll have R as 4, only 0 spaces, 4 characters per C1, 1, 2, 3, 4, and 3 characters by C2. And as usual, I'll get the cursor next line. When R is 5, I'll say stop. Now, let me summarize these values for you. So when R is 1, for n, as I'm doing this for 4 rows altogether. As usual, when n is 4, R, you might observe that it starts with 1 and ends up at 4. So this will be from 1 to n. So whenever we have any operation of variable R in any pattern, whether it is a left aligned right angle triangle or a right aligned right angle triangle or an equilateral triangle, your R is going to start with 1 and ends up at n. Now, you have to decide the variable for S. If you compare this pattern along with the right aligned right angle triangle, which has been done in the previous session, you will find that the patterns have got same amount of spaces. So S has got 1 at the beginning. Observe the logical expression which you have taught in the previous session. So it is again for 4 minus 1 as 3, 4 minus 2 as 2, 4 minus 3 as 1, 4 minus 4 as 0. So it means that this will start with 1 and end up at n minus r. So 1 to n minus r. So S has got not changed, R has not changed. Let's think of C1 now. What will be the value of C1? If you observe, the first character of C1 is always 1, but the last character of C1 changes, and this change is as per the value of R. So hence C1 will start with 1 and end up at R. Your C2, if you observe, again starts with 1 except the first one. So I'll write it as 1, but ends up at what? This is the only thing which is going to change from a right angle triangle to an equilateral triangle. So ultimately, the right hand side is the only one which has been attached to the right aligned triangle. And I know that this right hand side is entirely generated by the variable C2. So in this C2, if you observe, except the first one, everything is 1. But the end is again different. For R as 2, it ends up at 1 and starts with 1 and ends up at 1. When R is 3, it starts with 1 and ends up at 2. When R is 4, it starts with 1 and ends up at 3. If you think for a while and then if you assume, if you come back to a condition, you will find that is exactly equal to C1 but just 1 less than C1. So I can have 1 less than C1. So if it ends up at R, 1 less than C1 is R minus 1. So 1 to R minus 1. So substitute the values. 3 minus 1 is 2, 4 minus 1 is 3, 2 minus 1 is 1 and 1 minus 1 is 0. A dash can be equated as 0. So it means that an equilateral triangle will now be generated using 4 variables: R, S, C1, C2. R is going to have control of rows, S is going to have control of spaces, C1 is going to have control of the left hand side of the pattern, and C2 will have the control of the right hand side of the pattern. If you remember the variables, your R, whatever might be the triangle, it is still 1 to n. Your S is 1 to n minus r. Your C1 is now same as C of the previous pattern, that is 1 to r. And your C2 is just 1 less than the value of C1, that is 1 to r minus 1. So let's summarize this. First is R, which will go from 1 to n. S, same as it is 1 to n minus r. C1 is 1 to r and C2 is 1 to r minus 1. So always remember, an equilateral triangle has to be generated using 4 variables. A left aligned right angle triangle, only 2 variables R and C. A right aligned right angle triangle is using 3 variables R, S and C. A equilateral triangle is R, S, C1, C2. We'll see a program in the second part of this particular session. So let's see a program. Let's find a program to implement this particular pattern which we discussed. So we discussed that the equilateral pattern is going to be generated using 4 variables: R, S, C1, C2, where R will go from 1 to n, S will go from 1 to n minus r, C1 is 1 to r and C2 is 1 to r minus 1. So R, S and C, if you compare with the previous pattern, it is still the same values. So if I ask you to do this particular program, as usual, the initial task will be still same. Include the header files. Then I'll say void main. Declare all these variables. So I'll have variables as int n, r, s, c1, c2. Ask the user to enter the number of rows. Read the number of rows as n. Now let's put the entire task. Now again, before we put the task, we have to discuss about the looping structure. As usual, R is going to take the control of rows, and it will have a very less change as compared to S, C1 and C2. So since the variable R is going to have a least change as compared to S, C1, C2, your R will be outer loop. S, C1, C2 will be the inner loop of R. Now, will S, C1, C2 be nested into one another, or will they be independent? They will be independent in this particular structure. Your answer is true. They will be independent. Because when R is 1, you have to first generate spaces. After spaces are being generated, you have to print the characters which are on the left hand side. After printing the characters on the left hand side, then you are supposed to print the characters on the right hand side. So here, first spaces, then left hand side and then right hand side. All three are going to work one after another. Hence S, C1 and C2 are going to be independent loops. Let's write the first loop for our task. So I'll have a R loop at this place for. So I'll say R equals to 1, R less than equals to n, R plus plus. I hope you are actually virtually interacting with the contents which I'm writing. So do say this virtually. For. So now which loop I'm supposed to write? S loop. For S equals to 1, S less than equals to n minus R, S plus plus. What action am I supposed to do? What action am I supposed to do when S is working? Yes, you got it right. This has to be a space character. So let's say printf a blank space. I can indicate it as phi symbol, and phi can be later on written or equated to a blank space. Once S completes this task, who is going to take over? C1. So how do I write a loop C1? Say it. C1 equals to 1, C1 less than equals to R, C1 plus plus. What operation am I supposed to do when C1 is doing? I'm supposed to print an asterisk. So I'll say printf an asterisk. When C1 completes this task, what character has to be printed? Again an asterisk, but this time I'm supposed to print it using C2 loop. Let's print C2. For C2 equals to 1, C2 less than equals to R minus 1, C2 plus plus. So again I'm supposed to print an asterisk. So here I'll say printf an asterisk. Once C2 has printed its asterisk, before I go back and change the value of R, you should increment, or you should get the control to the next line. So I'll say printf / n, and then end the program by using get.ch command. So here, if you observe, we have only one pair of brackets controlling the entire R operations. Within that R, I have a S loop, I have a C1 loop, I have a C2 loop. If you wish, you can increase the level of complexity by using the brackets for S, C1, C2. Generally not advised. Because however, your S loop, C1 loop and C2 loop has got only one character each, hence not necessary to use curly brackets. So R loop is going to have S, C1, C2. If I put S loop in the mid, or if I place this S loop at the end, the entire structure is going to be disturbed. You will not get an equilateral triangle. Instead of that, you might get an obtuse triangle, where the triangle will have spaces after that. So never include spaces after C1, C2. It has to be in this particular order itself, R, S, C1, C2. Now, this is how a triangle which is equilateral in nature has to be printed. What if I ask you to print the inverse of this particular equilateral triangle? Suppose if I ask you to generate a triangle which has got a shape matching with this particular pattern. Assume that I have some numbers or I have some characters. In the previous videos, I have said how the inversion has to be done. How the inverse has to be done? If you are able to recollect it, it is equating the values of R in the reverse order. So your R will be now n, and it will go towards what? 1. Again in that, S, C1, C2 will still remain as it is. If I just show you the structure, I'll not write the entire code. You can say it virtually along with me. So this for R equals to N, R greater than equals to 1, R minus minus. And within that, the entire S, C1, C2 remains the same. They are not going to be changed even by a semicolon character also. Say that S loop for me. For S equals to 1, S less than equals to N minus R, S plus plus. Can you recollect the C1 loop? Yes, the C1 loop says for C1 equals to 1, C1 less than equals to R, C1 plus plus. And if you remember, the C2 loop is just one short of C1. So if C1 has started with 1 and ended up at R, C2 will start with 1 and ends up at R minus 1. So C2 equals to 1, C2 less than equals to R minus 1, C2 plus plus. So whenever there is an inversion, don't try too many combinations. Don't try to change too many values. Just observe that R, S, C1, C2 has to be written. So only R loop is going to change, S, C1, C2 will be as it is. If you try too many combinations, then probably you have to remember many combinations. So just change R, let S, C1, C2 as it is. Now, if I ask you to merge these two equilateral triangles vertically, suppose if I ask you to generate a pattern which is a diamond shaped in nature. Suppose if I ask you to generate this, let me draw this particular pattern for only say 3 rows. If I ask you to generate this particular pattern, this is again simpler. Whenever it comes to merge, you are supposed to write 2 programs. The top program is RSC1 C2. The second part is again RSC1 C2. But if this starts with 1, it ends up at 3. And this will start with 2 and ends up at 1. So if I ask you to write a program, then the program will be something of this sort. For upper part will be R equals to 1, R less than equals to N, R plus plus. Within that, S, C1, C2 will be as it is, which we have written in the first part of this particular video. And then your second loop will be for R equals to N minus 1. Got it right? R greater than equals to 1, R minus minus. And again in that, S, C1, C2 are supposed to be copied as it is. You are not supposed to change S, C1, C2 whether in the upper part or in the lower part by even a single instruction. But you have to write it twice. One to generate the upper part and second to generate the lower part. So do remember that an equilateral triangle has to be generated using 4 variables. R, S, C1, C2. Whenever it is an inversion, your R has to go from N and ends up at 1. Whenever it is a merging, you are supposed to write it twice. The first will start with 1 and ends up at N. The second will start with N minus 1 and ends up at 1. In the upper part, your S, C1, C2 has to be written, and the lower part again S, C1, C2 has to be written. So this is how we generate these equilateral triangles. Thank you.